Hello everyone. So in this video, we will learn how we can represent both quantitative data and categorical data in art. So we will have those bar plots, a histogram, the proportional table, the frequency tables and all. We will do that in art. Also, how can we calculate the mean, the median, the interquartile range, standard deviation. So we'll go over all of these things in today's session. So for the first thing that we need to do is we need to open our art studio. So from here, we will open the art studio. Again, just like the previous lecture, we will open a new file. So it's goes to file, new file and art script. So we will open this one. Now for this session as well, we will work on the diamonds dataset that we were doing in the last lecture. So if you remember, or let me just remind you once more, let me give you the name of the dataset, that is diamond, and it is been stored in my local file. To read that file, I can use the function read.csv, and let me go back to the local file where I have stored this CSV dataset. So it is under my F drive, this mass 2600009. So I will refer to this file. So I will copy this physical address, that is F math 2600009. So I will simply copy and paste that under quotation marks, and then I just need to change the path of it, give it a forward slash, and after that I have the dataset name to be diamonds1.csv. So I can just simply type diamonds1.csv. Now let's see if I've done this correctly or not. So if I run this out, it says that okay, the diamonds dataset is been loaded, because there is no, at the end, at the console, there is no error messages. I can also look at the head of this, head of the diamonds dataset, and also I can look at the tail of that diamonds dataset. So tail function gives the tail, and the head function shows the head of the dataset. So the head function gives you the first 6 rows, the tail function shows the last 6 rows. So we can see that there are column headings such as carat size, color, clarity, depth, table, cart, report, and price. So we have this numerous columns. Some of the columns are quantitative, some of them are categorical. For example, carat size. So these are just simple numbers. So seems like this is a quantitative variable. Color, it is in EEEKHG. So there are very few specific colors that are available. So it is a categorical variable. Similarly, clarity is also a categorical variable. Depth, the depth variable seems to be quantitative. Table is also quantitative. Cart, it is excellent, good, very good, something like that. So cart is also a categorical variable. Report is a categorical, and price is a quantitative variable. So for the first thing, we'll first work with the categorical variable. So categorical variables. So I have commented this out. So if you have hashtags, that means I won't read those lines. So this is just for commenting purpose, for easy readability purpose. So we have this categorical variables. For the categorical variables, first we can check how many. So I have mentioned that kata, there are excellent, good, very good, something like that. So how many diamonds are there who have excellent cut? How many diamonds out of very good cut? Something like that. So how many of them have an excellent cut? To look at that, we can do table. So table of command, the table function gives you in a tabular format how many of which category. Now I have diamonds, so I have to refer to the diamonds data set. And within the diamond dataset, I have to refer to this cut variable. So to refer to any variable in a given dataset, I have to use this dollar sign. So once I have plugged in this dollar sign, it gives me the list of variable options that are there. So for the time being, I'm interested in this card variable. So if I click on this card variable and hit, and if I highlight this and I press the run button, at the end in the console, you can see it says that it has 1276 diamonds which are of excellent cut, 165 are of good cut, 185 diamonds are of idle cut, and very good diamonds are 1064 diamonds, which are a very good card. Now, similarly, we can do a relative frequency table. So this is actually, so you can think about this to be a frequency table. So this table option gives you the frequency table. Similarly, we can make a relative frequency table. How to make a relative frequency table? So we have the same thing. So we still use the table option or the table function, but instead of that, we will also use, so first let me copy this table function, and top of that, I will wrap it up with another function. So we have table diamonds.cut, and on top of that, I will make this proportion.table, prop.table function. So prop.table function gives you the proportional values, how many of each category, and if I multiply this with 100, this gives me the in percentages. So we can say that 47.43 percentages are excellent, 6% are good, 6% are idle, and around 40% are very good. So this is the relative frequency table. So for the categorical variables, we can make the frequency table, we can make the relative frequency table. Also, we can make the bar plot. So next we will make a bar plot. So to make the bar plot, this is easy as well. So we can simply write the function bar plot, and again, we will have to use this table function. So table, because whenever we make the bar plot, we always have the frequency values for each category. So that's why we have bar plot. And so I'm wrapping this table function with the bar plot. So bar plot table, and then I have diamonds, and what variable I'm interested in. I'm interested in the card variable. So bar plot table diamonds card. So over here in the plot section, I can see the bar plots. We have this excellent, we have the good, the idle, and the very good. We can even export this. So we have this export option. So we can even export this. We can save it as an image. We can save it as a PDF. Even we can simply copy that. So we can just simply copy that and paste it into a Word file. So we have various options. Also, we can even zoom this function, zoom this graph. So if we zoom this out, zoom this in, so we can see more clearly how the cards are. So these are the various options that you can see from the plot. Also, what we can make is we can make a pie chart. So pie chart. So do the pie chart, we can simply write pie, and again I will use the same function, that is table. I can have diamonds. I will use a data set diamonds, and in the diamonds I'm interested in this card variable. So I have pie table diamond. So this will give me the pie chart. So I have this excellent, very good, good. Now, if you want to go back to the histogram, the bar plot that we did, if you simply click on this button, the left side button, it will move you back to the previous bar plot. And if you get to the right plot that you have, the next plot, then you can get back to this pie chart. So we can always go from one plot to the other. So these were the various various graphs that you can make from a categorical variable. Now let us think about the quantitative variables. So let us discuss about what are the graphs that you can make for quantitative variables. The first thing that you can do is a histogram. To do the histogram, first thing that you have to think about is what are the quantitative variables that you have. So if I scroll up, we can say that the quantitative variables that we have are carat size, we have price, we have table. So let me work on the carat size. So let me first do the histogram of the carat size. To do the histogram, I will use the hist function. So hist function, this will give me the histogram of the whatever variable that I want to input. Now I'm interested in this diamond data set, and in the diamond data set, I am interested in the carat size variable. So again, to refer to any variable in a given data set, we have to use the $sign. So hist function will give you the histogram of the caret size variable present in the diamonds data set. So if I click on this and hit run, it will give you the histogram. So this is kind of seems to be right skew, but not quite normal as well. So we can see this is the histogram that we can obtain of the caret size variable. Next, we can also do a box plot. For the box plot, again, we use the same function, that is the box plot function. That we have the box plot function, and we are interested in the caret size variable. So diamonds dollar caret size. Again, if I hit enter, we get the box plot. Now let me zoom into this one. So you remember these are the whiskers. This is the median. This is the first quartile. This is the third quartile, and the ones outside, these are the outliers. So seems like there are quite a few outliers in the caret size variables. So using the box plot, we can easily check if there are any outliers or not. So if we zoom this in, we can easily find out the outliers which are present or not. Okay. Another thing that we can do is the stem and leaf plot. So we will use a stem and leaf plot. Okay, to do the stem and leaf plot, we can simply use a stem function, and whatever variable that I'm interested in, that is in this case, I'm interested in the caret size variable of the diamond data set. So stem function, this will give you the stem and leaf plot, and this shows it in the console itself. It does not go to the plot section. It shows the values in the console itself. Okay, so these are the two ways. These are the ways which we can represent a categorical variable and a quantitative variable. Now, let us do some calculations. Suppose I want to find the mean. I want to find the mean of any quantitative variable. Suppose in this case, I want to find the mean of the caret size. So I can simply type mean. So mean function will give you the mean of any variable. So mean, and whatever data set I have and whatever variable that I wish to get from that given data set. So mean diamonds dollar caret size. This will give you the mean of that data set. Mean function gives you the mean of the data set. The median function. So the median function gives you the median of that given variable of the particular data set. So the median function gives you the median value. Also, another thing that we might be interested in is the IQR, the interquartile range. The IQR function gives you the IQR function gives you the IQ or the interquartile range of that particular variable. So these are the functions that you can use. You can also use a SD, the standard deviation function. So SD, that is a standard value function for standard deviation, gives you the standard deviation. So this will give the standard deviation. Also, you can write the variance. If you're interested in finding the variance, you can do the var function. The var function gives you the variance. One more important thing, as you are aware that standard deviation is nothing but the square root of the variance. So to double check that, you can also do square root of the variance of the given data set is diamonds dollar caret size. So if you check ST of the diamonds dollar caret size is 0.32 triple two, which is exactly equal to the square root of the variance. So both the answer matches. So you can either use the SD function, which is easier to use, or also you can wrap the variance under the square root function. So you can use any of one of them. One more thing which might be a very useful or a very handy thing is you can simply write a function called a summary. So if you do the summary value, summary of the diamonds of the variable caret size, if you use a summary, it gives you the minimum. So the mean, the first quartile, the median, the mean, the third quartile, and the max. So it gives you everything actually. So from here, you can easily find out the IQR. IQR is the first quartile minus third quartile minus the first quartile, Q3 minus Q1. So you can subtract these values to get what you've obtained using the function. It will straight away give you the median. It will straight away give you the mean. Both of them matches, right? Mean is 0.8701, which is the same that you obtained over here. Even the median matches. Also, important things, it gives you the minimum and the maximum values. And mostly, in most cases, the maximum and the minimum values are your outlier points. So you can get an idea what the minimum and the maximum are. So summary functions gives you the gist of all the numeric values. Also, if you're interested in finding the range, you can simply use the range function, range of the given variable, that is the caret size over here. So the range of the caret size variable is the minimum value is 0.3 and the maximum value is 2.02. What you can do is, so this gives the minimum and the maximum value. If you take the difference of these two, you will get the range. So to do this, you can use a difference function. So in the previous function, you can wrap that under the difference function, difference of the range of diamonds dollar caret size. So you just need to wrap that under the difference function. This will give you the range. So the range of this is 1.72. So these are the basic calculations, the mean, median, mode that you can calculate from R. That's all for today. Hope you like this video. Thank you.